Think about what would happen if I were to plot two variables with no relationship to one another on an XY axis. For example, the percentage of people turning out to vote in Fiji as an independent variable, and total political fundraising in Guatemala as a dependent variable. There should be no discernible pattern connecting these variables over time, and the distribution of the data will look something like this. You see a random pattern here on the screen. There's nothing but a blob of data. However, regression analysis will still draw a line through the middle of this data, and the equation of the regression line will give us a slope, a y-intercept, and a way to estimate fundraising in Guatemala based on every level of voter turnout in Fiji. The line will probably look something like this. It's right through the middle of the data. Of course, this line doesn't help us do anything. It doesn't make sense. We need to look at the p-value for this regression equation to understand the probability that this data and this line we drew resulted from underlying randomness, as opposed to any real connection between voter turnout in Fiji and fundraising in Guatemala, an unrelated country far away. For this example, the p-value might be 0.85 or 0.95, indicating an 85 or 95% chance that there is no real connection between the two variables, and that any connection regression analysis allowed us to identify, like through this line here, resulted only from random data rather than any relationship between the actual countries or the variables. However, now suppose we had a new independent variable, the margin of victory in Guatemalan elections, and a new distribution for the fundraising in Guatemala data. It might look something like this, whereas the margin of victory increases, there is less need to raise funds for victory because it's already established. A losing candidate's not going to win easily. A winning candidate's not going to lose anyway, or easily. The line we draw through this data using regression analysis would probably look like this. The p-value for this distribution might be something like 0.04 or 0.03, indicating only a 4 or 3% chance that this data, this straight line we see in the data, resulted from randomness alone. Instead, we think there probably is a connection between the margin of victory in elections in Guatemala and the level of fundraising in Guatemala. We can then use the p-value SPSS generates to assess confidence in our results and determine whether or not to use them in practice. Thanks, and I'll see you in Module 7.